Hello friends, so I welcome you all to watch a new video on electric field dipole. Okay, so in this topic we will find out electric field on the axis of a dipole. So how we will calculate, please see. See, this is a dipole. As you can see, two charges are separated by a small distance 2a. Okay, and in the same axis, okay, in the dipole axis, this is the dipole axis, and at a point A we have to find out the electric field at point A due to this dipole. Okay, so we have assumed this is the center of dipole. This is center of dipole, and from center of dipole to this point, the point at which we have to find out the electric field is R. Okay, and as you know that electric dipole moment can be defined as any charge multiplied by the small distance between them, between the two charges 2a. Okay, so we have defined electric dipole moment here, and as you know the electric field can be defined can be defined as electric field can be defined as k, the constant k, multiplied by the charge divided by the square of the distance between them. Okay, so here for EQ, okay, for charge EQ, what will be the electric field at A? We have to calculate. So what is this? See, E at minus Q, E due to minus Q at a point A, electric field at point A due to minus charge Q is K constant K multiplied by Q upon R. See, this is important to please watch it carefully. R, what is R? This is R. Okay, so from center of dipole to this point, this is distance R, and minus Q charge is plus A, because this total distance is 2a, so here this distance is A. Okay, so we have considered electric field due to minus Q is KQ R plus A. You got it? Okay, and now the second thing, the charge due to positive electric field due to positive charge, okay, at point A is nothing but KQ, okay, multiply by R. This is R distance, and plus Q will be subtracted from R minus A. This distance is R minus A. Did you get it? We are calculating distance between positive charge and this. What is the distance? If this is the total distance R, we have to subtract, okay, R minus A, then this gives you this distance. So R minus A square. Now, as you know that this point, if you can see that positive charge is very close to this point A, where we have to find out the electric field. So basically the magnitude of this charge, magnitude of electric field due to this charge will be much greater compared to E, electric field charge due to this negative charge. Okay, now what we have done is, so for sake of convenience, is this E plus Q, means electric field due to positive charge will be much greater compared to electric field due to negative charge at A. So simply we have kept E plus Q minus E due to negative charge. Okay, and if you take the common factor KQ out of them, what happens? Here you will see the R minus A square minus R plus A square. If you solve taking the LCM of these two terms, you simply get this expression, and when you will solve this, you will get KQ upon 4AR upon R square minus A square का whole square. Okay, now electric field, if you simplify further, you will see, if you will see k into 2a, here we have taken, if we have broken this term in 2a into 2r. Okay, so q into 2a we have kept together, and this becomes your electric dipole moment, and this is k into 2r. So these two terms are present, and this has become the electric dipole moment. Okay, and if you assume, as you can see, that r, this distance is much greater than this 2a distance, because we have assumed that this electric dipole definition, that two charges are separated by a small distance, so 2a will always be much lesser than, much smaller than r. Okay, so we have just taken that consideration, and then this equation reduces to how this this a square term will vanish. Okay, you will simply left with kp upon 2r, okay, upon r to the power 4, r to the power 4. So you will reduce it, you will left with electric field is k electric dipole moment upon rq. So electric field at point A, okay, due to this dipole is k, constant k, multiply by electric dipole moment upon rq. Okay, and this is the magnitude. So now we have to, since this is a vector quantity, so we will have to find the direction as well. So how we will find out the direction of this field. So as you know, as we have discussed in the previous video, or as you already know, that what is the direction of dipole moment? Always the opposite, always electric dipole moment direction will be always opposite to the direction of this charge. Okay, so here you can see this is, okay, this direction is along this line, and as you see that due to this charge q, electric field will be much, this force will be radially outward. This due to this charge, the electric field will be radially outward, and this will be in higher magnitude. Okay, so what is this direction? Simply overall charge, and electric field due to this charge will be a smaller, E minus Q will be a smaller. So what will happen? EQ, this direction, electric field due to plus Q charge, this positive charge will be the direction. This direction will be same as electric dipole moment direction, and this is, that's why we have considered the direction of electric field is the direction of electric dipole moment. You see? So this is it, and now we will come up with again, we will be discussing electric field on the equatorial line. Okay, so we will see this in next video.